are being recorded. Okay, Sarah, can I go over all the equations we need to know for the final? Uh, no, I'm not sure. I would need to look at your list of questions and go, oh, you need this and you need that. I don't have your review paper with me, so you're just gonna, oh gosh, I really wish I had that review paper because those are the questions. They're not page numbers. Um, you know what, Sarah, will you take a picture of that review thing, front and back side, and send that to me through Remind? I don't have that paper with me. So that's going to make things kind of difficult. Yeah, look at all the questions. 35, of course, you're going to ask the numbers, and I don't have that paper with me. All right, so Sarah, can you please take a picture of the front and back and send that to me through Remind? And you know what? I'm going to go grab my iPad so I can see it better. All right, I'll be right back. You guys can keep asking questions. I'll go get my iPad, and Sarah, please do send the pictures. Okay, let's see. Okay, I got those, Sarah. Thank you. Um, okay, I'm not sure how I saw that on my iPad before. I tried to send it to myself. Let's see if it, oh, there we go. Okay. All right, let me do that to page 2, and then I can get to your guys' questions. Thank you, Sarah. Okay, all righty. Let's see what your questions are. Okay, so you know what? Let me try to answer Sarah's questions. She helps so much by sending those. Okay, let's see. All right, so your question, Sarah, is all the equations we need to know for the final. Know about equations. I mean, I would say like rules. You need to know how to deal with absolute value, whether it's with an equal sign, with a less than sign, or with a greater than sign. Of course, you need to know how to factor. You need to know how to write interval notation. You need to be able to do word problems. I mean, I'm just kind of going through all these questions and just kind of saying what the topic is. You need to know how to write the equations of lines. So slope-intercept form, point-slope form, and standard form. You need to know how to do piecewise functions. Of course, you need to know all the equations of conic sections. So is it a parabola? Is it a circle? Is it an ellipse? Or a hyperbola? Okay. And then backside. You need to know how to deal with domain and range. Distance formulas, an equation you need to know. As I mentioned, all the different conic sections. Conic sections, finding the inverse of a function, synthetic division, knowing whether something's a factor or not, that's factor theorem, finding P of C, plugging in, C to see if either C is a 0 or X minus C is a factor. And then, all those last problems are just from chapter 5, which we just took a test on. Okay, so I don't know that I would really say equations you need to know. It's all the things that you need to know, okay? Okay, Alyssa, can I go over 25 and 26 on the review? Yes, I can. That's on the front page. Okay, so number 25 is asking us to switch colors, shall we? Pretty blue. Okay, so this is blue. Okay, review number 25. Okay, so they're asking us to graph x equals the absolute value of y minus 2. All right, when you have absolute value in an equation, I'd like you to know what you're going to anticipate for your graph. Excuse me, and that is some sort of V. Okay, so I'm expecting a V either that opens up or down or left or right. Okay, some sort of V in my graph. And then I'm going to make an XY table and I'm going to plug in values for one of my variables. You want to plug in for the more complicated variable. So the Y is inside the absolute value, so I definitely want to plug in for the Y. Okay, I'm going to start with -2, -1, 0, 1, and 2. I'm doing that so that I have some negatives, 0, and some positives. If these 5 points are not enough for me to be able to see where the V is, then I will plug in more. Okay, if I plug in -2 for Y, inside the absolute value I get -4, and the absolute value of -4 is +4. So there's my X. Okay, then I'm going to get 3, I'm going to get 2, I'm going to get 1, and I'm going to get 0. I can see right away that I'm not going to be able to see where the V is. So let's go ahead and plug in 3, and when I do that, I get 1. Okay, so I don't know if you see that 1 and that 1 right there. That tells me I'm going to be able to tell where the V is. Okay, so I'm going to do my graph in black. My X's go from 0 to 4, 1, 2, 3, 4, so I don't need anything else on my X-axis. Now my Y's go from -2 to +3. Okay, so X equals 4, Y equals -2. By the way, anytime students plug in for Y to figure out X, which is what you should do in this problem, for some reason they graph it wrong. They switch their X's and their Y's and then mess the whole thing up. All right, so 3, -1, 2, 0, 1, 1, 0, 2. And if I had just stopped there, some people would probably just draw a line going through those 5 points. But look at how this one extra point, 1, 3, shows me where the V is. And so my graph goes like this and continues forever, and then goes like this and continues forever. Okay, so that's the graph of this. You know, they didn't ask you anything, but they could have said, what's the, or is this a function? And no, it is not a function. It doesn't pass the vertical line test. Okay. All right. That's 25. Let's do number 26. All right. 26 asks us to graph x equals negative y squared minus 1. So you should recognize this from our last chapter. The x is not squared, but the y is squared. So this is in the form x equals ay squared plus by plus c. So that's a parabola. And since it's in standard form, I know that I need to have memorized negative b over 2a. Well, there is no by term, so that means my b is 0. Technically, it would be over negative 2, but that still equals 0. Now, you need to know if that's going to be the x coordinate or the y coordinate of your vertex. And so think about your next step. You're going to take that 0 and go plug it into your equation, right? So aren't you going to plug it in for y? So this is the y coordinate of my vertex. All right, so I'm going to plug in the 0 for y, and I get negative 1 for x. And by the way, since this x is all alone, the one that's not squared, that means it's going to open horizontally in the x direction, either left or right. Then I look at my a, well, it's negative, so I know this is going to open to the left. Okay, so let's go ahead and start our graph. I have on the x-axis negative 1, 0. That is my vertex. Since it's opening to the left, I know that my axis of symmetry is the x-axis. Okay, so I'm going to put a little dashed line right there, going through the origin, going through the vertex. Okay, and now I'm going to just plug in some more points just to get some points. I'm going to plug in for y. So let's do positive 1 and positive 1 and positive 2, both for y. Okay, when I plug in positive 1, I square it first, then make it negative, and so I get negative 2 for x. So negative 2, 1, and since that is 1 above my axis of symmetry, I'm going to go 1 below and get a 2 for 1 special. All right, then I'm going to plug in 2 for y. That gives me negative 4 minus 1 is minus 5. So 3, 4, 5, negative 5, 2. That is 2 above my x-axis, so I'm going to go 2 below the x-axis, and now I have 5 points to be able to draw a nice smooth curve. Oops, this curve, and there you go. Okay, all right. Let's see. Let's clear my text box. Okay. All right, that was Alyssa's question. Sarah, number 34 from the review. All right, number 34. All right, write an equation of the circle with endpoints of a diameter 0, 4, and 6, negative 2. All right, well, you need two things to be able to write the equation of a circle. Here's the general form for the equation of a circle. X minus h, the quantity squared, plus y minus k, the quantity squared, equals r squared. So the two things I need are the center and the radius. So if these are the endpoints of my diameter, isn't the center going to be the midpoint of those two endpoints? So to find a midpoint, you want to average your endpoints. So I'm going to add the x's and divide by 2, and then add the y's and divide by 2. That's averaging the endpoints. So my x's are 0 and 6. So 6 divided by 2 is 3. This is going to be my center. And then my y's are 4 and negative 2. When I add those, I get positive 2 over 2, and that's 1. So here's how much of my circle's equation I know already. X minus 3, the quantity squared, plus y minus 1, the quantity squared. And then it's got to equal r squared. Well, you could do the distance formula. If you were doing the distance formula, I would use c for the center and one of those 2 points, maybe the 0, 4. So you certainly could do that. But since I know this 0, 4 is a point on my circle, I'm just going to plug it into this equation that I've started writing. I'm going to plug in 0 for this x and 4 for this y. And then when I plug those in, I will get what my r squared is. Okay, so a 0 here, isn't that negative 3 squared is 9 plus, and then I plug in 4 right here. 4 minus 1 is 3 squared is also 9. And so isn't my r squared equal to 18? Okay, so instead of this r squared, I'm going to write 18, and there's my equation. X minus 3, the quantity squared, plus y minus 1, the quantity squared, equals 18. Okay? All right, you certainly could have done the distance formula also. You would have gotten the square root of 18 for your radius, and then you square it and get 18 for your equation. Okay, let's see. Gianna, can I do 3 or 4 on the review? Sure. Okay, those are two very different questions. I will do both of them. All right, so this is number 3. The absolute value of x plus 2 is greater than 3, greater than 3. You have to write this as two statements with the word or in the middle. Okay, the two statements are x plus 2 is greater than 3, or x plus 2 is less than a negative 3. Okay, you're going away, far away, because it's greater than. The distances go more than. So you can either go to the left or to the right, but it's more than 3. Okay, so it's greater than positive 3 or less than negative 3. Then I just solve each equation, or excuse me, inequality by subtracting 2. So I get x is greater than 1. Here I also subtract 2, so I get x is less than negative 5. If they ask for it in interval notation, let me just graph this so you can see the interval notation is so easy to get if you have your number line graphed. So there's less than negative 5, and here's greater than positive 1. And with interval notation, you want to make sure you start from the very left. So I'm going to go negative infinity to negative 5, parenthesis, because that's an open circle, union, left parenthesis 1 to infinity, and we always put parentheses on the infinities. And so there's your answer. Okay, that's number 3. Here is number 4. All right, simplify 12 over x squared minus 9 minus 2 over x minus 3. Okay, so the first thing I'm going to do is factor that x squared minus 9. It factors into x plus 3 times x minus 3. And so I'm going to get a common denominator. I'm trying to get this to be one fraction, so let's go ahead and just write it as one fraction. So x plus 3, x minus 3 is my least common denominator between those two denominators. So in the first fraction, my denominator didn't change at all. So my numerator doesn't change either. So 12. Then I have minus, and then didn't this second fraction's denominator get multiplied by x plus 3 to give me my new denominator? So I'm going to write minus 2, the quantity, x plus 3. Since that's what got multiplied in the denominator, I have to do the same thing to the numerator. And now a negative 2, I'm going to circle the 2 and the negative, needs to get distributed to each of those terms. Okay, so in my numerator, I have 12 minus 2x minus 6, and then over my denominator, simplify the numerator. My 12 minus 6 is 6 minus 2x over my denominator. I'm going to factor out a 2. I'm left with 3 minus x. This time I'm going to write out my denominator. It's x plus 3 times x minus 3. And I notice that that x minus 3 and that 3 minus x are opposites. So I'm going to cross them out in red, but since they're opposites, don't I get a negative 1? And I'm going to bring that in front of my 2. So here's my final answer. I have a negative 2 in the numerator, and in the denominator, now I only have x plus 3 left over. And that's my final answer. Okay? Okay, let's see. Matt, number 35 on the review. Okay, so here they're giving us a portion of a graph and they're asking us to draw uh, some symmetry. All right, number 35. I think I'm going to make this kind of big and I'm going to do each part in a different color, starting with black for the given. Okay, so here's their picture. Let's see, it goes up to 2 and out to 5. Up to 2, 1, 2, 3, 4, 5. Okay, so we have the point 0, 1, then 3, 2, and then 5, 2. All right, so that's our given. And then it says a portion of the graph is given. Use it to complete the graph so that it becomes symmetric with respect to A, the y-axis, B, the x-axis, and C, the origin. All right, so I'm going to pick my colors. We're going to go asymmetry with respect to the y-axis. A is y-axis. Okay, so that means I want to consider this y-axis as if it's my mirror. Okay, and anything that's happening to the right of this, I'm going to do the same thing to the left of this. Let me put my tick marks, 1, 2, 3, 4, 5. Wasn't quite straight, but okay, so in red, I'm going to do that. So this point is on the y-axis, it stays there. Okay, then the middle point over here is 3 to the right, so I'm going to go 3 to the left, but keep the y the same. And then the third point is 5 away. So now I connect this and this. That wasn't very straight. This and that is my answer for part A. Okay, part B, I'm going to do in blue. And B said symmetry with respect to the x-axis. So B is x-axis. So anything that my black graph was doing above the x-axis, now I'm going to do the same thing below. And so I need a -1 and a -2. And so that's 1 above, I'll go 1 below. That's 2 above, 2 below, and that's also 2 above, I'll go 2 below, and then connect these. Sorry, that's not very straight. Okay, there's my answer for symmetry with respect to the x-axis, and sorry, that's not very straight there. Okay, last part, we're going beautiful purple. Okay, so symmetry with respect to the origin. See origin. And so symmetry with respect to the origin is technically a half turn, 180-degree rotation about the origin. But if you take this red graph and reflect it over the x-axis, or take the blue graph and reflect it over the y-axis, you will get your answer for the symmetry with respect to the origin. So I'm going to have this point, and this point, and then let's connect. Oh my goodness. Draw straight on here. There's that, and that is my symmetry with respect to the origin. Okay, there you go, Matt. Okay, Tyler is asking what P over Q is. All right, P over Q is when they give you a polynomial. Let's say P of X equals, I'm just going to make something up, 2x to the fourth plus blah, 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 blah. And then let's say minus 6. All right, so you get your P's from this constant term right here that at the end of your polynomial. That's where your P's are going to come from. And then your Q's are going to come from the leading coefficient. So that seems kind of backwards because P comes before Q in the alphabet, and yet my P comes from the end of my equation. All right, and what I'm looking for is, for P, all the factors of 6. You're always going to have plus or minus, so let me start with that. And then factors of 6 are 1, 2, 3, and 6. And then my Q's are the factors, that's a bad Q, are the factors of 2. And so my list of Q's is going to be also plus or minus, and then 1 and 2. Okay, so now I'm ready to write my list of P over Q's. I'm going to go systematically. They will always be plus or minus. Here's what I mean by systematically. I'm going to start with the first P and divide it by 1, and then divide it by 2. And then I go to my second p and divide it by 1, I get 2. But when I divide 2 by 2, I get 1, and I already have that in my list. So I'm done. I don't write it again. Then I take 3, divide it by 1, divide it by 2, and then I take 6, divide it by 1, and when I divide 6 by 2, I get 3. That's already in my list, so I don't need to write that again. And then my last step is to write this in order from smallest to largest, because when you're looking for zeros of a polynomial, if there's a sign change, let's say between 1 and 2, I would like this list to be in order. Let me do it in order, and then I'll finish that comment. I have 1/2, then 1, 3/2, then 2, then 3, and 6. Okay, and maybe count 2, 4, 6, 2, 4, 6. Yep, I got them all. Okay, so I was saying, if I get a sign change between 1 and 2, wouldn't that tell me to look for a 0 on my list of P over Qs if there is one that lands between 1 and 2? And there is, 3/2. Okay, so that's why I put my list in order from smallest to largest. So, Tyler, to finish answering your question, the list of P over Qs is the list of possible rational zeros. So if I had this polynomial and they were asking me to solve for the 4 zeros, if there are any real and rational zeros, they will come from this list. Okay? All right. Okay, Antonio, could I go over all the types of word problems like 20 and 21 on the review sheet? Okay. 20 and 21. All right, so 20 is a, excuse me, mixture problem. I like to do these types of word problems in chart form, so just to get organized. And it kind of just takes away the mystery of, how do I write this equation? All right, so I'm going to make a chart. Yes, it takes a little bit of time, but then I'm not just sitting there staring at it going, I don't know what to do. All right, by the way, I'm mixing two things together to get a third. So I'm going to kind of make that line right there kind of bold, okay? And then if you don't have an equation at the top of your chart, then it's kind of worthless. Okay, so I want quantity times percent concentration equals amount of whatever stuff we're talking about. It could be amount of salt, it could be amount of silver. This particular problem happens to be about an acid solution. And so I'm just going to write amount of acid. Okay, so let's read this and we'll start filling out our chart. So it says a chemist has 16 liters. Well, that's a quantity. So I'm going to write 16L for liters, 16 liters of a mixture that is 65% acid. So for percentages, we don't write 65. We write the decimal equivalent of 65%. So 0.65. Okay, and then look at my chart. I already have two boxes, and it tells me at the top of the equation what to do with those two boxes. It says multiply 16 by 0.65, and you'll know exactly how much acid comes from that solution. It's 10.4 liters of actual acid. Okay. All right. Next it says how much of an 85% solution should be added to that first thing to make a mixture that's 70% acid. So how much, I don't know, I'm going to call it X for quantity. How much of an 85% solution, so I'm going to write 0.85. And then again, I have two boxes in my row, so I'm going to multiply them together to get the actual amount of acid, 0.85x. Okay, then it says, excuse me, we're trying to make a mixture that is 70% acid. So they told me the concentration of the mixture. What they didn't tell me is how much of the mixture I have. Excuse me, this is where I think it's so important that you have this bottom line bolded like I have right here, because I'm adding those two things together to get the third thing. So isn't my quantity 16 plus X? I'm adding those together. And so here's my third box. It's 0.7, the quantity, 16 plus X. And then my equation, without even needing to think, just falls right in my lap because it's right there. So I have 10.4 plus 0.85x equals 0.7, the quantity, 16 plus x. And now let's just do the algebra. On the right-hand side of my equal sign, I'm going to multiply 0.7 times 16 and get 11.2 plus 0.7x. If I take 0.85 and subtract 0.7, I get 0.15. So 0.15x equals, and then I'm going to take my 11.2 and subtract 10.4. With all these decimals, I would strongly suggest using your calculator. And then my last step is to take 0.8 and divide it by 0.15, and I get 5.33333. I know that's 5 1/3. And honestly, after I've done all this algebra, I don't even remember what my x was. That's the other benefit of doing this chart. Oh, that's right. It's the quantity of 85% solution. And I know my quantities are in liters. And so I'm going to say 5 1/3 liters of 85% solution. And there's my answer. Okay. All right. Let's see. The other word problem is 21. And it is an investment problem. Okay. So it says part of 14,000 is to be invested at 9% and the remainder at 12%. All right, before I get started on my chart, I just want to talk about the whole pile of money thing. So if I tell you I have $14,000 here, just in $1 bills, so it's a big, huge pile, and I say, hey, I'm going to take some of this away, okay? And you say, well, how much are you going to take away? I'm going to take away X, okay? So this X dollars, X amount of dollars, I'm going to take it away and invest it in a whatever, a CD or stocks or bonds or whatever. So then if you knew you started out with 14,000 and I just took away X, doesn't that mean the remainder is 14,000 minus X? If I take this 14,000 minus X and I add X, don't the X's cancel, and I get a total of 14,000. You need to be able to label what each part of your money is that you're going to be investing. One of them I'm going to call X, and the other one will be 14,000 minus X. Okay, now you do need to know the equation up at the top of this chart if the chart's going to be helpful. And this is a very pretty equation. It's principal times rate times time equals interest. Do you agree it's pretty? P-R-T-I, pretty. Okay, principal means how much money. Rate, of course, is the interest rate that we're going to either pay or collect. And then time, I keep time in there just because it makes the equation pretty, but all of these problems talk about annual interest. So the T is just going to be a 1, and then my I is interest. Okay, let's fill in the chart. It says part of 14,000 is to be invested at 9%. Let's write our 0.09. Don't you dare put 0.9. That would be equivalent to 90%. They said 9%, so it's 0.09. The remainder at 12%. Okay, so I'm just writing the rates, but now let's talk about the principal. How much are we going to invest in each? Well, I don't know either one, so I'm going to call one of them X, and the other one is going to be 14,000 minus X, like we talked about here in my little pile of money. Okay, if I add those two under P together, my X's will cancel when I add them, and I'll get 14,000 as my total, and that's exactly what I have. Okay, so now don't I have 3 boxes in my row? I'm going to multiply them all together to get my interest box. So 0.09x when I multiply those all together, and then 0.12, the quantity, 14,000 minus x. Now there's one thing I haven't put in yet in my equation, or from my words rather. It says how much should be invested at each rate in order to yield an annual interest income of $1,500. That's total interest, and so that goes at the bottom of the interest column. Okay, and then without even having to think, there is my equation. Very, very easy. Okay, let's do the algebra for this. So I have 0.09x plus, now I'm going to do a little bit of calculating before I write down. So 0.12 times 14,000 is 1680 minus 0.12x equals 1500. Okay, if I take 0.09 and subtract 0.12, I get negative 0.03 3x. So then when I take 1500 and subtract 1680, it should make sense actually that I got a negative, because when I divide my negative by negative 0.03, I get positive 6,000. There's no way you can get a negative answer for money. It wouldn't make sense. Okay, and then, as I mentioned earlier, I wouldn't even remember what my X stood for unless I had this chart. But I come up here and I go, oh, that stands for $6,000 that I'm going to invest at 9%. And then I plug it in here and I get $8,000 that I'm going to invest at 12%. Okay, so that's $6,000 at 9% and $8,000 at 12%. And there you go. Okay, I hope that was helpful. Oh, yes, Sarah, I did get those. Otherwise, I wouldn't be answering these questions. Thank you very much for sending that to me. Okay, let's see. All right, that was Antonio's questions. Okay, Alyssa, domain and range. Yes, this is something that students struggle with a lot. Okay, so domain stands for what your X can be, and range stands for what your Y can be. Excuse me, I'm curious where domain and range come up on this review, because it's a very good review, you know. Alyssa, do they talk about domain and range on here? I am sure not seeing it. Did I mention this is a really good review? Okay, so I'll just give you an example of a graph and then we're going to move on. Okay, let's say I have a graph that goes, I don't know, it's part of a parabola, let's say. Okay, it starts here at -2, 1, 2, 3, and then it goes here, and then it goes up like this, and I'm just kind of making things up here. 2, 3, pretend like that's 4. Oops, 1, 2, 3, 4. This would be 5. And I'm going to look this up. I'm going to put an 8 right there. Okay, let's say I gave you this graph and I said, state the domain and range. Well, since domain is X, I would make sure that my brain is thinking in the X direction. Don't think up and down, think X direction. Okay, so doesn't the X's start at, the X's start at -2, and then that's less than or equal to my X, which is less than or equal to 5. So I'm looking from the very left to the very right. It goes from -2 all the way to 5. Okay, now that's my domain. For my range, now I'm going to change the way I'm thinking, and I'm going to think up and down. Okay, so what's the lowest this goes to? -1. So I would write -1 is less than or equal to y, which is less than or equal to 8. Okay, and that would be my domain and range. All right, I'm not sure if that's what you're looking for, Alyssa, but there's an example. Okay, Sam, could I go over the rules of absolute value equations? I'm not sure if you mean equations, you might mean inequalities. Actually, I'm going to do all 3 of them. All right, I'm going to go super, super basic for all of these. Let's just go x plus 3 in absolute value equals 5. And then I'm going to do x plus 3 in absolute value is less than 5. And then I'm going to do x plus 3 in absolute value is greater than or equal to 5. Okay, so when the equation has absolute value but an equal sign, I just really want you to be able to picture of a number line. Okay, so if this is 0, then exactly 5 to the right gets you to the point +5. but 5 to the left gets you to the point -5. Okay, so if you can just picture that, then it makes this so easy for all of these. Okay, so for the equation right here with the equal sign, let me do this in red, I guess. I'm going to write x plus 3 equals +5. I'm going to write the word or, and to the left here, I'm going to write x plus 3 equals -5. I just like to write the positive to the right and the negative to the left because that's what a number line does. Okay, and then you just solve each one of them. So for this x plus 3 equals +5, I'm going to subtract 3 and I get 2. Here I'm going to subtract 3 and I get -8. Okay, and if you go back and plug those in, it will satisfy that equation. If I plug in a -8, -8 plus 3 is -5, but the absolute value of -5 is 5. If I plug in 2, 2 plus 3 is 5, and the absolute value of +5 is 5. So those are my two answers with the word or in the middle. X equals -8 or X equals 2. Those are your two answers. Okay, for a absolute value of X plus 3 is less than 5, again, I'm going to refer to this number line. Isn't that less than 5 saying the distance from this middle point, 0, is less than 5? So wouldn't that be shading in between here and here and shading in between there and there? Okay, so you're staying really close to that middle point or your home, like Mama's saying, stay close to home, less than 5. Okay, and then these circles would become open circles because I didn't put an equal sign on this inequality. Okay, so some of you have learned for absolute value with a less than to think of it as less than, and you write two statements with the word and in between. There's nothing wrong with that. I just think this is so much easier. So I'm going to write it like this. If I want to be in between -5 and 5, if you just write one statement, it just makes it so much easier, I think. I'm going to write -5 is less than whatever's in my absolute value, so x plus 3, which is less than 5. I'm saying I want to be between -5 and +5. And then you just solve this. So I'm going to subtract 3, subtract 3, subtract 3, and I'll be done. So I get -8 is less than x, which is less than 2. And that is your answer. Okay, and if they wanted it in interval notation, that's so easy because I've got it written like this. It would be parentheses, -8 to 2, parentheses. That would be interval notation for that problem. Okay, and my last one is with an absolute value is greater than or equal to 5. Okay, so on my graph, I'm going to use the same graph, but it's going to start getting a little crowded. Since it's saying greater than or equal to 5, okay, if you are right here in the middle at this 0, equal to 5 would be at +5, but I want to go greater than that. And then equal to 5 going to the left would be at -5, but I want to go away from that middle point. Okay, so less than that. So I'm going to write two inequalities with the word or in the middle. And how are you going to remember to say or in the middle? You're going to say this is great or. And so I'm going to write x plus 3 is greater than or equal to 5. I put the +1 to the right. Or x plus 3 is less than or equal to -5. Look at the graph and you can see greater than +5, less than -5. And then you just solve each of those. So x is greater than or equal to, subtract 3, I get 2. Here, subtract 3, I get -8. And that's my answer is x is less than or equal to -8, the word or, and then x is greater than or equal to 2. And that summarizes absolute value with an equation, an equal sign, a less than sign, and a greater than sign. Okay. Alrighty. Okay, there we go. All right, we have about 12 minutes left. All right, Brandon, do you know if on the final it will tell us when to answer in interval notation? Yeah, well, it'll either tell you, Brandon, or you'll look at your answers and you'll go, oh, all the answers are in interval notation. If you look at your answers and it says something like x is greater than or equal to 2, well, then they're doing it as an inequality instead of interval notation. So I'll just use that as an example to give you this advice. When you guys start a problem, instead of just immediately going to your scratch paper and starting to do your work, just glance at your answer choices. I'm not suggesting you do that to try to guess, but look at them. Say they're asking you to write the equation of a line, and you're starting to write it in point slope form. And then you look at all the answers, and they have them in point slope form. Well, if you hadn't looked at the answers at all, to kind of give a little clue, you might write your equation in point slope form and then go, oh, they usually ask us to change it to slope intercept form, or they usually ask us to change it to standard form. So if you start doing that on your work and then you go to pick your choice and you go, oh, they left it in point slope form. Well, you just wasted your time changing it to slope intercept form, right? All right, so or standard form. So I'm just suggesting glance at your answer choices so you can see how did they do it. Did they write it in interval notation? Did they write the equation in standard form or leave it in point slope form? Look first so you don't waste your time doing stuff that you don't need to do. Okay, so let's see. Okay, Sydney, can we go over 27? Yes. Okay, that is called a piecewise function. So number 27 says that f of x, isn't that pretty purple, equals either 2 plus x or 2 minus x. And then, of course, they give us the if part. Here it's if x is less than or equal to 2. And the second one is if x is greater than 2. Okay, so I suggest you make an XY table for each of those parts of your function. Okay, we have two pieces of our function. So the first one that I have to the left here, I'm going to use if x is less than or equal to 2. I'm going to start with 2, and then I'm going to go down from that. So 1, 0, -1, that should be plenty. Okay, and I'm going to plug it into this first function because that's where x is less than or equal to 2. All right, so if I plug in 2 for y, I get 4, then 3, then 2, and 1. Okay, for my second one, let's switch colors, even though that's so pretty. I'm going to pick some x's that are 2 or greater. Now, because that says x is greater than 2, some people want to skip to 3. You cannot do that. You have to start with 2, but watch what I'm going to do. I'm going to put an open circle right there on my XY table. So I don't forget to put an open circle at 2, 0. So I plug in the 2 right here where I have it underlined in black at my 2 minus x. Okay, and then let me go back to my chart. I'm starting with 2, and then I want x's that are greater than 2. So I'll do 3 and 4, and let's go up to 5. Okay, so I plug in the 3, I get -1, then -2, -3. Okay, I'm now ready to graph. Let's see, my x's start at -1 and go up to 5. 2, 3, 4, 5. My y's go from -3 up to +4. Okay, so let's plot our points. 2, 4, 1, 3, 0, 2, and -1, 1. And remember that purple XY table was from the top part of my function right there, 2 plus x, but it was from when x is less than or equal to 2. So here's my x equals 2. It starts there and goes to the left. I know this looks like it's going down, and sorry, that's not very straight. That's supposed to be a ray. But yes, it is going down, but it's also going to the left, and that's what x is less than or equal to 2 does, is it goes to the left. So that point at 2, 4, that's the start of it, and then it goes to the left, or less than x. Okay, for my second part of my piecewise function, I start at 2, 0, but oh, thank goodness I put that open circle right there because I probably would have forgotten. So I have an open circle at 2, 0, and then I go to 3, -1, 4, -2, and 5, -3. So it starts at that open circle and then goes to the right. And there is your piecewise function, and it is a function. Hey, Bear, come here. Come here, Bear. You want to see my puppy? Come here, Bear. Bear, come here. Come say hi to my students. Come here. Come here, Bear. Okay, Bear, has a cute little scarf on. Say hi. Tell my students good luck on your finals. Good luck on your finals. While you're taking your final, Bear will certainly be sleeping. Huh? So cute, huh? Okay. You're a good boy. All right. There's your little puppy vision. All righty. Where are we? I'm done with that piecewise function, by the way. Okay. We have about 5 minutes left. Let's see, that was 27. There you go, Sydney. Antonio's, they're going to be a none of the above option for the questions on this final. Yes, absolutely. You will have A through E choices. A through D will be answer choices, and then E for every single one is none of the above. Okay. Yes, I know that makes it definitely more difficult. Okay. Audrey is asking for 28. Okay, there's domain and range. Thank you. Who is that? Audrey. Whoever was asking about domain and range earlier. Motivational puppy viewing. Cute. Okay. Brandon, I just did 27, but probably when you typed that, I had not. Okay, but earlier somebody had asked about domain and range, and I just kind of gave a picture of a function and showed domain and range. There's number 28. I hadn't noticed that. Okay, so give the domain and range of this function. G of x equals the square root of x minus 9. Okay, so there's two different ways about giving domain as well as range. There's analyzing the equation, which is difficult for some people to do. And then there's just looking at the graph. So that previous example I did was showing you domain and range from the graph. Let's say you're going to analyze this. Well, the stuff inside a square root, I do not want it to be negative because otherwise this won't be real. So I'm going to take this x minus 9 and say, if I don't want it to be negative, it's okay if it equals 0, or if it's positive, it just can't be negative. So I'm going to say it needs to be greater than or equal to 0. So then I solve for x, and I get x is greater than or equal to 9. That is your domain. And if I look at my answer choices and they give me the answers in interval notation, then this would be equivalent to bracket 9, comma, infinity, and then right parenthesis. Okay, that's your domain. Now your range, that range is y, okay? G of x is another name for y. Well, this y is equal to a principal square root. And a principal square root is typically positive, but it can also be 0. So that means my y needs to be greater than or equal to 0, okay? And that is my range. And if they write that in interval notation, it would be bracket 0, comma, infinity, like that. Okay, so I'm showing you it as an inequality and also in interval notation. Now, if you can't do what I just did, analyzing the equation, then you should probably graph this. Okay, this is going to end up being half of a parabola. The vertex will be at 9, 0, and it'll go up from there. Okay, and so if you look at this graph for the x's, look at my domain. Do you agree it starts at x and gets bigger to the right? So x is greater than or equal to 9. And if you look in the y direction of my graph, it starts on the x-axis and then goes up from there. So isn't that y is greater than or equal to 0? Okay, there you go. That's domain and range. Okay, we are very close to being done. Where am I up to? All right, I'm not going to be able to do all these questions. 16 and 17. Let's see if I've done those yet. No, I have not. Okay, I'm going to show you, well, I can do both of those. These are probably going to be my last questions, okay? All right, so number 16, if any of you have not finished taking the gateway, this is an example of solving a quadratic equation. Okay, this is a sum of two perfect squares, so it's not factorable. I'm going to get the x squared all alone, so don't I need to subtract 16 and then divide by 9? That gives my x squared all alone. Then I'm going to take the square root of both sides. However, this is a quadratic equation, so of course I'm not going to forget the plus or minus. That's how we get our two answers for our degree 2 polynomial. And so I'm going to get plus or minus. Now my square root of 16 is 4. The square root of 9 is 3, but then I also have a square root of negative 1, and that gives me I. So plus or minus 4 thirds times I. All right, so there you go, two answers for 16. And then 17, you've probably forgotten about this concept. And people who are not in my class, I'm not sure if your teacher taught it to you this way, but here's what the book was teaching when they had x to the fourths like this. They were asking us to solve this as if it was in quadratic form. Excuse me. So I'm going to use the letter t, and I'm going to go right here to my variable in the second term. I'm going to let t equal x squared. So doesn't this equation turn into 9t squared minus 10t plus 1 equals 0? So I just turned a fourth degree polynomial into a quadratic trinomial, and that happens to be factorable. So I'm going to write 9t times t, and then this is a 1 and a 1, and both negatives, and let's double check. That's 9t squared minus 9t minus 1t is minus 10t, and then a negative 1 times a negative 1 is plus 1. All right, so I get t equals positive 1/9 and positive 1. Well, that's the answer, two answers for t, and that makes sense that I got two answers because it's a quadratic in terms of t, but the original problem was degree 4, so I'm supposed to have 4 answers. So that's where I'm going to take these answers, the 1/9 and the 1, and I'm going to plug them in for t. So 1/9 equals x squared. To solve for x, I'm going to take the square root of both sides, and don't forget plus or minus. So I get x equals plus or minus 1/3. So there's two answers. Then I'm going to take my t equals 1 and set it equal to x squared. I'll take the square root of both sides, but don't forget plus or minus, and I get x equals plus or minus 1. So these are my 4 answers, plus or minus 1 and plus or minus 1/3 to my original equation. Okay, I know I didn't go over all of your questions. I got, I don't know how close I got. Yeah, fairly close. But it is 9:30 and I'm done. All right, I hope that was helpful to you and people in my class. We will answer more questions tomorrow in class. All right, I hope that was helpful for you, and I will see you tomorrow, and good luck on your finals, everybody. Good night.